But one thing you want to make sure is if you see variables that are alike, you don't want that. You want to clean it up. And in doing so, I usually leave my constant on the right side. That's usually what I'm going to be doing, because it makes it easier to find intercepts if you need to do that. In this case, the y's they cancel out. All you're left with is an x, a negative x that is, because 2x minus 3x is negative x. So you're supposed to divide both sides by negative. So 4 divided by negative 1 is negative 4. Okay, so that is the mistake here. This is not the right line. X equals negative 4. You should know this. Maybe have this on your study sheet if you need. It's going through negative 4 here. Okay, so this is the correct. This is wrong, right? I will leave this here because I'm saying, hey, x is equal to 4 is here. X is equal to negative 4 is there. So this is not wrong to say, because you're clearly saying that negative 4 is what is here, right? So you're good. I think that's it for mistakes, hopefully. If you find them, please let me know. Is there anything else? I think I'm going to move on. Even if you're a little stuck, I will move on because I want to do multiple lines at the same time. Okay, so let's go skip a few pages here. I'm going to get you to go to page 9 here. Remember, right now, all we're dealing with is lines. We haven't done inequalities yet, so that's where it's headed. So this is on page 9. And I will kind of just skim through this because we know how to use our TI-84 by now. But basically what you want to do in order to graph it is obviously rewrite all the equations so that y is isolated. That's basically what you want to do. Press y equals, enter your equations into y1, y2, and so forth. Look at how many stars there are. This is almost like one of those legal documents, right? Or a contest you're about to enter is like footnote, 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 right? And we all just go, yeah, sure. Always clear all old equations. Plot 1 needs to be turned off. And by now you know why. Because we're not using L1 and L2. We're not using points that we're given. It's not going to be the case in this unit. You only have the option of using x as your variable. If the first value is negative, we use the negative button, not minus. Okay? I think you all know that already. I would talk about understanding your window. Okay? So if you don't adjust your window, you may have the line outside your window, right? So you kind of have to move this so that the line is visible. Okay? And so you all kind of know already about it. And you all know the cheats. Right? If you're into video gaming, there's always a cheat out there, right? So some of the cheats are using one of the zoom features, zoom fit, zoom standard. Zoom standard is a saver, like if you're ever lost in space, your window is like not showing anything, and you're getting an error, anything like that. Zoom standard usually fixes that, and then you can work from there again, okay? So I will leave this. I will not talk about window. I will go to page 10 here. I will also skip the zoom functions because those are things I've covered already. So let's go to this part. This is where I want to focus my attention today before I start inequalities. Okay. So for each of the following, we will rewrite it, graph on the calculator, and determine the y value when x is equal to 7. As well as finding the intercepts. We're not going to use technology. We're going to do that by hand, as I've shown you already, but you could use technology if you choose to. And then determine the x value when y is equal to 15. We're going to do all of that for both of them. So let's go ahead and do that. Okay. So for this equation right here, it's already the way we want it. Okay. Format is good. I just want to make a note for you, note. Format is good. Okay. I want the variables on one side, the number on the other side. We're good. Let me zoom into that side for now because we're going to spend some time there. You can do this. There you go. All right. I is rewrite. And by that I mean making it look like this. And basically the main idea is leave y isolated. So we're going to go 2y is equal to 6x plus, because the 6x comes over the equal sign positive. And then it's plus 30. Then we divide both sides by 2. And we're left with y is equal to 3x plus 15. What do we know about this? Just by looking at that, I need you to make sure you understand. The slope is positive, so I expect my line to look like this. Sometimes we miss that and we draw it the other way because we just go by our x-intercepts. And that means you made a mistake on your x-intercept calculation, most likely. Okay? And the y-intercept is what? It's positive 15. So that's an observation you can make right off the bat just by looking at that. Okay? We're gonna skip this step for now. Graphing on our calculator. 3. What does it say? Find the intercepts. So we're gonna go x-intercept, y-intercept. I'm not saying you have to do it this way. I like it that way, right next to each other. So I used the original. Watch this, folks. I'm going to use this one here. Okay, that's the one I used for this one. When you're finding the x-intercept, y is equal to 0. When you're finding the y-intercept, x is equal to 0. That's something that I won't be writing down every time, but for now, since we're still learning, sure. Right? So you end up with negative 6x is equal to 30, basically, because the 2y turns into 0. Divide both sides by negative 6. X is equal to negative 5. So one of the x-intercepts is negative 5, 0. You will realize again why this is important to have. When I ask you to graph this, you're going to need to know your intercepts for scaling purposes. Okay? Then let's find the y-intercept. The negative 6x turns into 0. So you're really just left with 2y. 2y is equal to 30. You divide both sides by 2. Watch the sign. Sometimes it's negative. So this is 15. 0, 15. This is a good sign. The 0, 15 confirms what I have up here. If you do the math and it doesn't jive, these two don't jive, you know you've made a mistake somewhere. So you need to go back and correct it. So there you have your intercepts. We're done. Can I ask you to do the same? Before we move on, we're going to leave the space for 4 and 5. Right? I want to ask you to do the same, just to practice and warm up with this side right here. Try to do the same with this one. I don't like the format it's in right now. Should I do that one at least so that it doesn't derail? Yeah, we'll do that. Weird format. That's what I'm going to say. It's a weird format. I don't like it. So I'm going to go negative 5y minus 4x. And this x over here, I'm going to bring that over. It's going to come over negative. And guess what? The 100 here, I'm going to bring that over to the other side. So the x comes over to this side. The 100 comes over to the other side. Positive, because it's negative on the left side. Then it's negative 5y minus 5x is equal to 100. And I think from here on in, you can do everything else. So rewrite it into that y is equal to mx plus b. We'll skip the second part and then find the intercepts. Go for it. And then we'll correct it before we move on, okay? All right. I'll take this and rewrite it. So I'm bringing the 5x over positive. I divide both sides by -5. 5 divided by -5 is -1, so it's just negative x. 100 divided by -5 is -20. So that'd be the rewritten form. This one will be important to do so we can enter it into our calculator later on. And just to remember, slope is negative, so we expect our line to go like this, and the y-intercept is -20. Okay? So that's an observation you're making. We're going to skip the graphing part on our calculator. If I start with this is new for students. They're like, oh, whoa, right? So we've talked about the window and whatnot, but you already know that. So we're going to go to the third option here, which is the intercept. So let's see how he did here. So you can use this one. I prefer to use this one here. Okay, so for x-intercept, the y turns into 0, so you end up with -5x is equal to 100. Divide both sides by -5. X is equal to -20. So it's -20, 0. You do the same thing for the other side. X is going to be 0, so you end up with this, and you'll find out that you end up with the same. Y is equal to -20. So you're not finding an equation, you're finding a point. Remember that when you're finding the intercepts. So there are your intercepts. So they're both the same in terms of their numerical value, which is good. Okay, for the fourth option for both of them, okay, it's asking, if you go up here, determine the y value when x is equal to 7. You should be able to plug it in here and just do it that way. But we can also use our calculator. I'm trying to think here. What should I do? I think I'll just plug this in. So x is equal to 7. Plug it in here and see what we get. You can choose to plug it into any one of these versions. I'm going to plug it into this one. So let x be equal to 7. So that would be y is equal to 3 times 7 plus 15. That would be 21 plus 15. And that would be 36. Okay. Y is equal to 36 there. So you found the point 7, 36. Okay. Same with this side here. I will use this one to get me started. So y is equal to -7 minus 20. So y is equal to -27. So you found the point 7, -27. Okay. So that's what you're doing there when x is equal to 7. And I haven't left myself enough room for the other one. Let's use the technology with that one. I want to do that. Can we enter both of these into our calculators right now? Type that into your calculator, y1 and y2. And I'm curious to see if you can find a window actually that works here. Go to y equals, turn off plot 1. Mr. Dixon, what happens if I forget plot 1? Chances are nothing is going to happen, but sometimes it won't let you graph. That's what the danger is here. So 3x plus 15 for my y1. And then -x minus 20 for y2. And let's hit graph. Let's see what happens. I haven't done anything to my window. It's not a great window. So I'm going to try zoom standard. I'm just going to do a 10 by 10 by 10. Zoom standard. And why am I not seeing things? If you look at the intercepts here, -20, -20 for x and y intercept. So one of them is -20 here and -20 down here, correct? So we need to change our window a little bit. My x min, I'm going to change that to -30. And my y min, also -32. Make sure I can see these intercepts here. Let's hit graph again once we've made those changes. So now I see the red line, no problem. I still cannot see the y-intercept for the blue line for my first line because the y-intercept is 15 here. So let's go to window and let's change our y max to like 20. It's 15, so I'm going to go a little over, right? 20. So it's graph. And so that's a pretty good window right there. You see both lines, you see where they intersect, you see both of their intercepts. So that one is a pretty good graph there. Now, you're gonna want to watch for this one. We're gonna solve this part right here. Determine the x value when y is equal to 15. Pay close attention to this part. It might be a little challenging, but I will do this. Let's go to our notes here at the bottom. So for the fifth step here, I'm gonna let y2, I'm gonna call this y2 even though it's y3. But I'm gonna first figure it out for this equation, then for that equation. I'm gonna let y2 equal to 15, and I'm gonna use second, trace, intersect. Right? Second trace 5. So let's do that. Go to our calculator. We're gonna let y3 be 15. And hit graph. And there it is. Okay. That's the 15 line. So where does it hit the first one? This is my first line, so we're going to find that intersection there. Second, trace. Yeah, intersect. And watch this, there's 3 lines, right? So you are on the blue one, right? So that's the one you want to pick. So you hit enter. And now it automatically takes you to the red line. We don't want that one. So you go up and down arrows. I'm going to go arrow up. Gets you to the blue line. Arrow up one more time. Gets you to the black line. So you want to find the intersection between these 2 lines here. So you hit enter one more time. And when it says guess, enter. So that is the point. So when y is 15, x is equal to 0. And we kind of knew that already. Okay. Don't despair. I'll do these multiple times. Okay. So same here. For the 5th step, y2 is equal to 15. Second trace, calc. Right? Oh, sorry. Second trace 5 for intersect. There's a problem, right? Can we see the intersection of those 2 lines, of the 15 line and the second? We cannot. So we need to go to our window and change the x min. Bring it further back. So x min, I'm going to make that negative 50. Hit graph. There it is. So that is the intersection that I want right there. So I'm going to go second trace 5. You cannot see anything right now. Which line am I on right off the bat? I'm on the blue line. Look, everything is blue. So I'm on the blue line. I don't care about that one. I want to know the intersection between these 2 lines. So I'm going to jump up or down arrow. It doesn't matter. Just cycle through it. Right? That's the black one. That's the red one. Then it goes to blue. If I keep going arrow up, I'm back to the black one. And I'm going to go a little closer to that one. You don't have to, but I'm going to hit enter there, and then it jumps to the blue line. I don't want that one. So keep cycling through until you get to the red one. So you basically, it's asking what point on the second curve do you want me to start looking? So there it is. Hit enter, and then enter one more time when it says guess. So there's your intersection. So when y is equal to 15, x is equal to negative 35. So that's the skill here. When there's multiple lines, use up and down arrow to jump and cycle through the lines to find it. And we'll do more of that, so rest assured. Okay. All right, let's keep going here. We're going to graph both of these lines on the same grid. Okay, so that's going to be another skill here. I think this is a little overkill, the steps here on page 11. Determine the point of intersection of the two or more lines. Okay? First step, enter each line into Y1, Y2, and so forth. Press second trace intersect. Select the first line by using up and down arrows. Then press enter. Select the second line using up and down arrows, then press enter. And then it'll say guess, press enter one more time to start the process. You should see the X and Y values for the point in question. You may have to adjust your window to make this happen, just so you know. You want to see where they meet, okay? Okay, so determine the point of intersection for the lines created by the equations above, the ones we just did. So we're going to say, all I need you to say is do this. Second trace, intersect. We're going to find where they meet. Use your calculator. Make sure you follow along on this one. I'm going to go to y equals and get rid of the last one. Okay, I'm going to get rid of whatever, the 15. I don't need it anymore. It's just these two equations here that I'm wanting to see. Hit graph one more time. So this is the point of intersection between the two lines. Okay, so let's go ahead and find it. In this case, because you only have two, you're not going to have to bother with the up and down arrow. But I'll show you that anyway. So second trace 5. You're on the blue line, correct? I'm going to try to make the cursor show up. There it is. I use the right arrow to make it appear. You hit enter. It immediately jumps to the second curve. If you were to use up and down arrow, it would just cycle between the blue and the red. Blue and the red. Okay? If you are on the red one, just hit enter and then enter one more time. And there it is. It's negative 8.75, negative 11.25. That's the point of intersection between the two lines, which I will ask you to find quite often. Okay? Now let's graph this thing. Let's graph both of the lines on paper on the same grid. So here it is. Let's just see what we're graphing first and foremost. Normally I'll give you space to do the math and then graph it. Okay, but the first line is this. This is the first one we did. And the x-intercept is negative 5, 0, whereas the y-intercept is 0, 15. Okay. The second line is y is equal to negative x minus 20. And we had negative 20, 0, 0, negative 20. And here we go. Let's graph this thing. I need to make sure I go all the way to the negative 20s or a little bit more to accommodate for the x-intercept here, and also negative 20 on the y-axis to accommodate for that one. In terms of the highest, I need to make sure I go all the way to 15 here to accommodate for that one. So this is kind of giving you a little bit of the window parameters. So let's go ahead and do that. Maybe I'll use a ruler to help me out to make this a little prettier. Let's see here. This will be 5, 10, 15, 20. 5, 10, 15, 20. That'll do it. Just barely, but it'll do it. So that's the scale I choose for my x-axis. And x and y is already labeled. If it's not, you're going to want to put that on. There are arrowheads on the axes, so that's good. Let's do the same thing here. I'm going to go negative 5, negative 15. Sorry, negative 5, negative 10, negative 15. I'm running out of runway here. That's okay. I'm just going to extend it. It's okay to just label every other one. It's still consistent. Everything is worth 5. I think I used too much space, but whatever. And then 5, 10, 15. That'll be enough for that part. And then just plot one line at a time. So my first line has -5 here, -5, 15 going up there. And that's my first one. And I'm going to label it. Choose one of the ends to do this. Don't label the inside, because quite often you'll cross it out if you do that. And then there's -20 here, and -20 on my y intercept. And that's line number 2. And I will be labeling that one on the ends here. I'll label the point of intersection right here. This is -8.75, -11.25. And you've got yourself a system. This is a system. This is a system of equations, right? A linear system. As soon as you have more than one line, we call it a system. Do you remember solving by substitution, elimination? You remember that? You would have to do all of that work just to find this point right here, which we did with second trace 5. Okay? So that allows us to do more stuff than just finding that one, right? Because it's going to be just part of the work. We're going to go further than that. All right. What we're going to do now is I need you to be quite confident and being able to do this fairly quickly before we move on to inequality. So I'm going to go to page 12 here. And I'm going to ask you first and foremost to, here's a bunch of equations. I want you to rearrange all of these equations here. I was able to fit that in here, so you should be as well. So by this I mean I want it to look like that. Okay, every single equation you rewrite it into that format right here. Then I want you to find me the x-intercept and the y-intercept by hand. Like, don't use your calculator to do that. You could, but I want you to find every single one of these by hand. For now, I will say optional. This part right here, I'm going to make it optional right now. Like, so basically what I'm saying is if x is equal to -5, find what y is. But I'm going to make that optional. Right now, I want you to just focus on filling in this whole thing here. And then we're going to find the intersection between all of those lines, okay? That's going to be the next step. For now, I'm just going to give you some time to do this part. And then we'll focus on the other steps that follow, all right, guys? So I'm going to give you some class time to do that. Later on, I'm just going to give you the answers so you can copy them down or check if you got them right, and then we'll move on with the next thing. Should you be done before all of us, okay? Go ahead and already answer 2, 3, 4, 5, 6, 7. If you're done all of this before we're done, you may go and do that already. You should be able to do that. Okay. Pause here. But I'd like you to keep them that way, especially if it's not a finite fraction, meaning it just keeps going on your calculator. Keep it that way. That's what I would suggest, because our answers are going to be way more accurate if you keep the fraction. So I should have done this earlier, but I'm going to do this with you. Enter every single equation into your calculator here real quick. So watch how I do the coefficients, folks. I would strongly suggest you enter the 3/5 like this, and then slap the x right next to it. Okay, -6. See here again, I'm going to go -17 divided by 3. And I cannot emphasize how important it is to get your signs right. As something as simple as getting your sign wrong is going to yield a completely different graph. Okay, so here it is, 3x plus 12. This one, I just want to clarify what I did here. Right? As soon as I see any fractions, I get rid of the denominator by multiplying both sides by it. Okay, so both of them had thirds, so I just went ahead and multiplied both sides by 3. Just so you know, let's say you take a intro course in university, and there's a 3 and a 4. 3 and a 4, whoa. You could multiply everything by 3 first, and then multiply everything by 4 again. It's okay, you can do it as many times as you need to get rid of all denominators, okay? Anyways, then you end up with this clean version because all the thirds have been canceled on the left side, and the 3 times 4 yields a 12. You bring stuff over, do whatever you need to do, you end up with this equation here. That's the one I'm going to enter. So I'm going to go -1 divided by 2x. It's okay to go -0.5 there, plus 6, okay? So those are my 4. I do all 4 at the same time. So go ahead, hit graph on this in this case. 1, 2, 3, 4. It's actually not bad. I look at my intercepts. Look at your intercepts here. If you were to go zoom standard, you would just have to adjust a little bit because there's a 15 that's outside the 10 and the 12 that's outside the 10. So I'm going to hit it as zoom standard here. And then I'm just going to adjust. I'm going to go window for this 12, which is a positive. I'm just going to change my x max to 15. And my y max should be at least 15. I'm going to go 20. That's much better. Look at that. Isn't that pretty? Another problem I have here, I don't know if you see it, this intersection isn't quite visible. So the calculator may throw a fit. Okay? So what I'm going to do is I'm just going to decrease my y min a little bit. My y min, I'm going to go -20. Why not? It doesn't hurt. So I see everything crossing, everything intersecting. It's overwhelming, right? Whoa, right? Like, what's going on? I'll show you how to do this. So I already have the answers here. It doesn't matter. We'll go and so if I wanted the intersection between y1 and y2, right? Those are the two that you want. So why not turn off, you go over the equal sign and just turn off the ones you don't want to see. And then if you hit graph again, it's only going to show you y1 and y2. Okay? Then you go second trace 5, and you can close your eyes and just go enter, enter, enter 3 times. And it will find it every single time. Okay? So that's how I got that answer. I just write down those coordinates. And then what about y1 and y3? You hit equals. Just turn on those two. Hit graph. There's that intersection. Second trace 5. Enter, enter, enter. And there you have it. Okay? So you just keep repeating this process until you find them all. Okay? If you are comfortable having all of them turned on at the same time, watch this, because it's going to save you some time if you know how to do this. What's y1 and y2? Blue and red, correct? You're paying attention, right? Blue and red. So I'm going to go second trace 5. I'm on the blue, correct? You hit enter. It immediately jumped to the red one, which is y2. Hit enter, enter, boom. There it is. If you want to find the intersection between Y1 and Y3, go check your colors. Y1 is blue, Y3 is black. So I'm going to go second, am I too fast here? Second trace 5. Blue is the first one, perfect. And then I'm going to cycle through until I get to the black line. See it, everything turned black here. You hit enter, enter again, boom, it finds it right there. So if you're comfortable having everything turned on, you just have to go check which colors. Hey, by the way, it just tells you up here, Y3, right? So if you want to do Y1 and Y4, second trace 5. I am on Y1 right now. I'm going to hit enter, and I'm going to cycle through until I get to Y4. So if you don't want to look at the color, just look at your entry here. So Y1 and Y4, hit enter, enter one more time. It's going to go find the only point where they meet. That's this one right here. And just make sure you round those ones to 2 decimals, and then you're fine. Okay? All right. Lots of typing, lots of calculating. Let's go ahead and I'm just going to ask you to do this yourselves. It's going to be a bit of a pain, and you know where to do this one. Okay. Nowadays, you all have your phones. Back then, I couldn't do this, right? If you want to graph this, you take a picture of what you've done here with all the intercepts for every line, okay? And then you have your phone on your, right beside it, and then just say, I'm going to do Y1. You go plot the 2 intercepts, graph your line. Then Y2, label it right away, by the way. Then Y2, plot the 2 intercepts, graph your line, do the thing you need to do. So I want you to have all 4 on here, and then check my answer key, because I do have an answer key for that. In addition, because, can I just say this one more time? You need to be good at this. You need to be good at rewriting and graphing. Here is a version 2.0 of what you've just done. Very important. Again, these are optional here. The side entries are optional. I just want you to do this part right here the same way you've done it today. Don't use your calculator, like don't do the second trace thing. Do it by hand. And then, lo and behold, guess what? You have another grid here where you can fit all 5 of them on. Okay? That's your homework. And you might think it's a lot, I know, but right now that's what you owe to yourself, is get really good at this so that the rest may be smoother for you. So 12 to 15, and obviously you've done most of 12 already. Thank you guys. See you tomorrow. And we're going to start inequalities tomorrow, okay?